So, again, if we're looking for total distance, what we have to do here is, first of all, here comes the sign diagram again. We're going to complete a sign diagram for V of t. Okay? Complete a sign diagram for V of t, the velocity, to determine change of direction. Alright? And here's the key. We want to look for the places where the velocity equals 0 and changes from positive to negative. Okay, it's possible, remember, we could have a point of inflection if it's 0 and we don't change direction. Okay, maybe we're just stopped at a traffic light, but we're still going to keep moving forward after it turns green again. So that would be like a point of inflection in our velocity graph. Okay? Here, though, we have to break this up to get our total distance traveled. We're going to go from 0 to A, and then we're going to go from A to B. Okay? All right. So total distance traveled, we're taking the integral of the velocity from 0 to A and the integral of the velocity from A to B. Now, you might be thinking, okay, one of those has to be negative, one has to be positive. All right? So what you could think of in terms of that is we're going to be adding the absolute values of these. All right? And this is nice because that covers no matter which one is negative, it's going to be made positive. All right? Because you guys remember from kinematics, we could start at 0 and we could start traveling in the negative direction. But then we could stop. There's where f of a equals 0. And then we could start going in the positive direction to wherever b is. Okay? So from 0 to a it would give us a negative area, but we're taking the absolute value to make it positive. Then we go from A to where we're stopping at B. That's already positive, but we'll take the absolute value just in case for that one. Okay? All right, so let's actually try one of these that has a mathematical function, not just a picture to look at the area. Okay? This says here, a particle is initially at the origin and moving to the right at 5 centimeters per second. Okay? So, here we have our origin 0, and at time 0, remember we're going to put our times at the top, and let's put our velocity. Okay? Our velocity at this moment is 5. Okay? So our velocity is 5, and it's positive 5 because we happen to be moving to the right. Okay? It accelerates with time according to A of t equals 4 minus 2t centimeters per second squared. Okay? So A of t is 4 minus 2t. Okay? Now, first of all here, they're asking us to find the velocity. How would I find the velocity? The integral of acceleration. Excellent. Okay? Our velocity is the integral of acceleration with respect to time. Okay? So, we have the integral of 4 minus 2t dt. So that would be 4t minus 2t squared over 2. So it's just minus t squared. Plus c. Now we haven't done this in a little while, but how do we find c? Okay, what point are we going to plug in? if this is our velocity, what?
5. X equals 5.
Okay, we'll plug in 5 for what?
For X. What's the second? What's in? Wait.
For the velocity, okay? So this is going to equal 5. What time were we going 5?
0.
0, okay? So there we go. We have a point 0.05. Now we can calculate the fact that c equals 5. So now we have our velocity function. Our velocity function is 4t minus t squared plus 5. All right? So that right there, that's part A. Does that make sense? Okay. Now, we want to sketch this. You guys can sketch a parabola, I think. Just looking at our velocity, one of the things that we're going to have to find is where does the velocity equal 0? Okay? So where does the velocity equal 0? We have negative t squared plus 4t plus 5. How are we finding this? You guys know how to do this. Factor it. Maybe even make flip all the signs. Since it's equal to 0, that'll make it easier to factor. So t squared minus 4t minus 5. What does this factor into?
Plus 5.
Minus 5 plus 1 to get a minus 4 in the middle. All right. So this has a change in direction at t equals 5 and negative 1. Okay. Now we're only looking at the time from 0 to 6, right? So let's look at our sign diagram real quickly here. Here's negative 1, here's 5. I already know that my velocity is positive in here. What's it going to be to the right of 5? We're doing a sign diagram here, guys. So over here, I know my velocity is going to be negative. So there's my change in direction. Okay? So I have my function. I know there's a change of direction at 5. So going back here, how am I going to find the displacement of my particle? Integrate velocity. Do I need to break it up or no? And if I'm finding displacement, come on guys, wake up.
Yes.
Would you can break it up?
Do I need to make separate intervals for displacement, or do I need to make the separate intervals for total distance? Which one is it?
What's total distance?
For the total distance, okay? Come on guys, you're like comatose here.
Hey, I would have answered the question. I had my hand up.
So displacement, we're simply going to integrate from what to what?
From 1, negative 1 to 0.
Well, we're looking at from 0 to 6, right? So the integral from 0 to 6 of 4t minus t squared plus 5 dt. That's for I, okay? For total distance, what are we going to have? The integral, we have two integrals.
From 0 to negative 5.
From 0 to 5,
0, 5, 5, 6.
and then from 5 to 6, okay?
Would you use -1?
No, because we were told just time from 0 to 6, okay? So we'll take the absolute value of, hello? You guys can wait for 2 seconds to catch the end of this. We got to take the integral of this from 0 to 5 and take the absolute value plus the integral here of 4t minus t squared plus 5 and take the absolute value. That will give us our total distance traveled. So displacement, one big integral from start to finish. Total distance, you got to take the pieces separately. All right? All right. Have a good day.